Okay, so let's take a look at review section 5. All right, that's what the R is. So factoring polynomials. We talked a little bit about factoring on Friday. Let me just briefly go over that. I'll just do super quick review of what we did before. So if I gave you something like this, 2x plus 4, and I asked you to factor, the very first thing you're going to look for is to see if there's a common factor. See if there's anything in common with this and with this. Is there anything that divides evenly into both of those? And yeah, there's a 2 that divides evenly into both of them. So what do? Is sometimes I say this, I pull out a 2, all right? When I say I pull it out, I'm dividing it out, okay? So I'm going to put a parentheses, and when we factor something, we want to find out what times what equals this whole thing right there. What times what equals 2x plus 4? Well, pull out a common factor, it's 2. What's left over if I divide a 2 by this? What am I left over with? It's just an x, and then if I factor out or divide out a 2 from this 4, what do I get? I get a 2. So now this is factored. So that would be the answer if they ask you to factor that. All right? We did that on Friday. We did it on the board back there. Let's do another one, and then we'll move on to the new stuff. So what if I asked you to factor this? Okay? We're still asking you to do the same exact thing. I'm asking you to factor it. So the very first thing you do, we're going to look at some special factoring today, but this is kind of like your normal, everyday, run-of-the-mill factor problem. So I want to just, first thing I always do to see if there's anything in common with both of these terms, okay? I got a 6x squared and I got a 9x. I got to look at this and I got to look at this. Is there anything in common with both of those? Anything that can divide out evenly? Yeah, a 3. And there's an x as well. There's a 3 and an x. Let's do the number first. Because there's a 3 that divides into 6, and a 3 also divides into 9. Is that the largest number that divides into both of them? Yeah, it is. What about at 9? Some people might say, well, 9 goes into both of them. No, 9 goes into 9, but does 9 divide evenly into 6? No. 6 divided by 9, that doesn't come out even, okay? So, but a 3 does. A 3 divides into both of them. What else is here? Not just numbers, but I got these variables. I got an x squared and I got an x. So what shows up in both of them? Not just one of them, but in both of them. There's an x. There's an x right here, there's one x right here, and there's an x right here. But some people look at this and say, Mr. Hamrick, there's an x squared here. But is there an x squared in this one? No, there's not. So there's only an x in common with both of them. Everybody got that? Yeah. So I'd put that next to the 3. Put a parentheses. Now, let's find out how many times that 3x divides into this. Well, it's simple. It's 6 divided by 3 is 2, and x squared divided by x is x. Put a plus. Do the same thing here. We're dividing this 3x by this. So 9 divided by 3 is 3. X divided by x is 1. 3 times 1 is 3. There it is. It's factored. Do you remember, I don't know, a week or two ago, I said something like this. I said, we're going to start off. Well, let's just do this. I'll talk about that in a second. We had this on a test, basically, didn't we? Where you had to distribute through like that. That was on the test. So what would I get if I distribute this through? 3 times 2 is 6. X times x is x squared. Plus 3 times 3 is 9, and then an x. Would you agree? Yeah. Do you remember, I don't know, a week or two ago, I said, we're going to start with the answer, and we're going to eventually come up with the question? Yeah. Remember me saying that? That's what factoring is. Now we're at that point, okay? Now is what I was talking about back then, okay? And that's kind of what you're doing. You're kind of starting off with the answer, and you're trying to find out what is being multiplied to get to this. Well, 3x times 2x plus 3 is being multiplied together to get this. Those are your factors. Your factors are 3x and 2x plus 3. We good? All right. Let's move on. They call this other common factors. Let's write that down. Other common factors. So I'm going to show you several different scenarios here. And you're going to have to be able to look at them and recognize which one is which. This is what I'm talking about, where it's really, really important. So here's the first one. We call this one the difference of two squares. Difference of two squares. This is actually fairly easy if you recognize it. You got to recognize it, okay? So let me show you a basic version of the difference of two squares. I guess if you want to call these formulas, you can. They're not really formulas, but if you want to think of it that way, I guess it's okay. But x squared minus a squared. All right, so what if I asked you to factor this? First of all, is there anything in common with both of them? Yeah, but this just means I have two x's and I got two a's. So if I have two x's here, two a's here, do they have anything in common? They don't have anything in common. So I can't factor out a greatest common factor like I just did earlier, okay? I got to have another way. So what I'm trying to do is find out what times what is going to equal this. And I'll show you right now just how to do it, okay? This is one you should just be able to look at and then write down the answer, okay? No lie. First of all, let's look at the name, difference of two squares. In math, what does the word difference mean? It means subtract. Do you see subtraction here? Absolutely, right there. So it's got a difference, right? Of two squares. Well, I got two things. I got one thing here, and I got one thing here, and both of those things are being what? Squared. That's right. So do you recognize that this is a difference of two squares? All right. I'll do one. Let's see. Yeah, well, I think what I'll do is I'll show you this, then I'll go to the example, then I'll show you a different one, then I'll show you an example. We'll do it like that, okay? So this is a difference of two squares. This is how you factor a difference of two squares. Remember, factoring is finding out what times what is equal to that thing. What times what is equal to x squared minus a squared? Well, they're going to show you exactly what it is. And then we're going to do an example, maybe one or two examples. So on a difference of two squares, this is what I always do. I always make one of them plus and one of them minus. Okay? And then what I'm going to do is put an x first, because if I distribute this, if I went backwards and multiplied this together, x times x is what? X squared, correct? Yes. Well, how am I going to get that a squared? This and this should be a what? An a. And this is factored. Okay? Now, we're going to put some regular numbers in there, but this is kind of like the general form for a difference of two squares. Let's do an example. This is example 2. Example 2. And the problem says to factor, or they say factor completely. All right, factor completely. So it's x squared minus 4. Now, we just did the difference of two squares, and I'm doing an example. So what do you think? What kind of factoring is this? I don't have anything in common, do I? Do I have anything in common with x squared and 4? No, there's nothing in common. So I can't do that. But it's always the first thing I look at, though. When I give you something, I always see if there's anything in common. If there's not, so I just move on. So, but I look at it, I'm like, hey, wait a minute. This is one of those special common factors. Other, or you could call it special. Sometimes I'll say that. These special factoring problems. What kind is it? Well, we've only learned one kind so far. So what kind do you think it is? A difference of two squares. How do I know it's a difference of two squares? Because there's the difference, right? It's got to be minus. What if it was a plus? No, wouldn't work, because plus is sum, right? It's not a difference. So it can't be a plus. It's got to be a minus. Now, is something being squared right here? Yeah, an x is being squared. Now look at this one. Is something being squared to give you 4? 2 is being squared. That's right. So is this a difference of two squares? Absolutely. So how do I factor a difference of two squares? I just put two parentheses next to each other, make one plus, make one minus, right? And then what goes first? X. What goes next? 2. Don't put a 4 there, because it's 2 times 2 has to be the 4. We did this on the test. I gave you this, and then I asked you to multiply it, didn't I? Remember that? I gave you one. I don't think it was the same numbers, but it was one very similar to that. So what if you don't have to do this? This is your answer. It says factor it. We're done. All right? But I'm just showing you that this actually does equal x squared minus 4. Let's do it. Let's do some FOIL on this. So first is x squared. Outside is what? If I multiply the outside terms, what do I get? No, I did the first to get x squared. The outside, these two right here, negative 2x. Okay? Did you forget this already? Just had a test on it. What about the inside? What's the inside? Plus 2x, right? And then the last, negative 4. Simplify it. X squared. Add like terms. What happens with a negative 2x and a positive 2x? They add up to 0, right? You can say they cancel out. That's fine. But technically, they add up to 0. So would you agree that this does equal this? Yeah. And it must, right? I mean, we didn't do it right if it doesn't equal. Now, you don't have to go through this, but you could kind of check your answer if you wanted to. I'm not going to force you to do it, but you could check your answer just to make sure that this and this are the same thing. Remember, don't make them both plus, don't make them both minus. One's a plus, one's a minus, and they both have the exact same things inside of there. You okay with that? Let's do one more. It's not in my notes, but I think I can make one up on my own. So what if you had this? What if you had, oops, I lied. Maybe I can't make it up on my own. So 9x squared minus 25y squared. What if I asked you to factor that? First of all, is there anything in common with both of these? 9 and 25, does anything divide evenly into 9 and 25? No, there's nothing. Okay, what about the x's? Nope, don't have any x's over here. What about the y's? Nope. Nothing in common, right? Always look for that, though. That's the first thing I always look for, to see if there's a greatest common factor. There's not. So let's look to see if it's one of our special kind of factoring problems. Is it? Well, you got the difference, so we're halfway there. Is something being squared to give you this? Yeah, what's being squared to give you 9? Oh, what's being squared to give you 9? 3. 3 is being squared, okay? What's being squared to give you x squared? An x. What's being squared to give you 25? A 5. What's being squared to give you y squared? A y. So, is it a difference of two squares? Absolutely. So, what do? I put my parentheses. What do I put in there first? Plus and minus. Now, what is being squared to give you 9x squared? 3x. That goes there and that goes there. What's being squared to give you 25y squared? 5y. And this is 5y. And that's it. Is that easier than division of polynomials? Okay. I scared you for nothing, didn't I? Just wait, though. All right. So, let's move on. That's enough of that. Okay, let's do this. Ready? So that's one down. That's the easiest one. All right. Started off with the easiest one. So this one is called a perfect square. Perfect square. All right. So what in the world does that mean? Well, I'm glad you asked. Let's do this. Let's go x plus a squared. They always like to do this. Instead of putting like just regular numbers in there, like x's and a's and all that, just to give you a general idea what's going on. We know how to do this. We did this on the test, right? Didn't I give you something that was squared? No, I think I gave it to you once, and then I gave you one that was cubed. No, like you write it twice. Oh, yeah. Okay, I see what you're saying. Yep, you write it twice. Exactly right. Okay, so if I was to multiply this out, I'm not factoring right now, but I want to show you what the factoring looks like and how to realize if it's a perfect square or not. All right? Just bear with me. If I was going to FOIL, or if I was going to multiply this out, what would I get? X plus a times what? X plus a. It's not my answer or anything. I'm just multiplying this out, okay? Let's do FOIL. We just did FOIL. First gives you x squared. Outside, what's x times a? Yeah. Do you mind if I put a first? Make it ax. Is that all right? Okay. Let's do the inside. What's that? It's another ax, isn't it? What about the last? A squared. Let's add some stuff up. X squared. We can add these up, can we? Before they canceled out because one was negative, one was positive, but we don't have that here. So what's 1ax plus 1ax? 2ax. That's it. Plus 2ax. Plus what? The a squared. Okay? So this is equal to that. You with me? Go ahead.
Why would it be 2ax instead of ax squared?
Because you're not multiplying them. Okay? When you add, you just add the coefficients. See the 1 in front of it? Right? Okay. So I got one of these plus one of these gives you what? Two of these, right? If it was ax times ax, then it would be a squared x squared. Okay? But it's not multiplying. You're adding. It's a good question. Let's do another one like this, and then we'll talk about the factoring part. Let's do another one. Now, first of all, why is it called a perfect square? Because you're taking something and you're squaring it, okay? So you're taking the x plus a and you're actually squaring that. So these are exactly the same thing, all right? Let's do one instead of x plus a. What do you think? X minus a. Let's see what we get for that. It's the same idea, except we're going to have a negative in here. And just where is the negative going to be? Well, I write it x minus a times x minus a. That's the perfect square, okay? And I'm actually thinking ahead. There's something we're going to be doing later on, not this section, but later on, that's going to come back to this perfect square stuff, okay? And it's going to be super important, all right? So get this stuff down now. Later on, we're going to see something that we're going to use that perfect square for. It's going to be a small part of a bigger problem, all right? But right now, it's just the problem, but we're going to use this later on. So if I FOIL this, let's do it a little quicker now since we've already done one of these. That'd be x squared minus ax, and then plus a squared. Why is it plus a squared? Because negative times negative is positive. You see that? Let's finish it off. X squared. So it's negative 1 at ax minus 1ax. What's negative 1 minus 1? It's negative 2, isn't it? Right? You add the opposite. So it's negative 2. So it's negative 2 what? Ax. And then you just stick that plus a squared on the end. What we're going to do is we're going to start with this thing and end up with that thing right there. Okay? What you have to do is just recognize it. All right? Let me find one. Yeah, there we go. I don't know why they go in this order, but they do. This is example 6, if you want to look in the book. Example 6. Thought I was changing the color here. Let's change the color. Let's see. Can you read that purple-pink color right there? Is that bright enough? Is that too hard to read? All right, I'll just go back to white. All right. You got this in your notes, right? From here to here? All right. I'll scooch it up just a little bit right there. All right, example 6 says this. It says factor completely. I'm lazy. I'm just going to write factor. And here it is. X squared plus 6x plus 9. Now, before we do this problem, what I want you to do is I want you to recognize something here. notice on the ends of these perfect squares. Remember, these are perfect squares. It's not a difference of two squares. It's a perfect square. Because remember, the difference of two squares didn't have any middle term, did it? Okay? But look at this. This has an x squared and an a squared, or an x and an a. Do you see the x and the a? All right? Now, so that x and that a, okay, if it has those two things, and if you double it, that gives you the middle term, doesn't it? Do you see that? So if I take whatever this is and take the square root of it, all right, what do I get? I get an x, all right? Or what? That's going to confuse you more than anything. What's being squared to give you x squared? X is, right? What's being squared to give you a squared? A. If I multiply those together and double it, that should be my middle term. That's your check to see if it's a perfect square or not. Okay? Let's take a look at this. What's being squared to give you x? It's x. What is being squared to give you 9? 3. If you double that, see that's 3x, right? If you double 3x, what is that? It's 6x. Is that 6x? It is. So what kind of factoring problem is this? It's a perfect square factoring problem. So that means I could just write this and say it's a perfect square. So what goes where? Well, everything's positive. What was being squared to give you the x squared? X. What's being squared to give you the 9? 3. And there you go. That's a perfect square. Okay? You just have to recognize it. So what's the check? How do you decide if it's a perfect square or not? Well, square root, right? Or what's being squared to give you this? What's being squared to give you this? All right? Well, that's an x. That's a 3. Multiply them together, that's a 3x. But then you double it. If you double it, does it equal this right here? Yes, it does. If it equals that thing in the middle, that middle term right there, then it's a perfect square. And then you can just write it as a perfect square. Once you recognize it's a perfect square, it's not hard to factor at all. The hard part is recognizing if it's a perfect square or not, okay? Okay, let's do another one. Example 7. I was hoping they'd give you another one. So example 7. It says to factor, and it's 9x squared minus 6x plus 1. Now, we're doing it right after this whole perfect square thing. So you kind of know that it's going to be, right? But you're not always going to know. On a quiz or a test, I could give you a whole bunch of problems and it just says factor. And you're like, whoa, does this have a greatest common factor? Is it a difference of two squares? Is it a perfect square? I got to check to see which one it is. First of all, does anything divide into all three of these evenly? No. You might think 3 does, because 3 goes into 9, 3 goes into 6, but 3 doesn't divide into 1, right? So there's nothing, no greatest common factor, right? So is it a difference of two squares? Well, first of all, there's no way because it's got 3 things, right? Difference of two squares only has 2 things. So it could possibly be a perfect square. Let's see if it is. How do we determine if it's a perfect square? Take the square root of this. What's that? 3x. Take the square root of this. What is being squared to give you 1? 1 is, okay? Times 1, times 1. And then what do? You multiply them and then do what to it to see if it's a perfect square? Times it by 2, double it, right? Is this 6x? Is this a perfect square? Absolutely. Watch how easy it is to factor it once you realize it's a perfect square. We just put one set of parentheses, and what do we do? What do we put on the outside? A squared, right? Now, look at this. You got a minus here, though. You had a plus before, so you put a plus here. So what sign's going to go in the middle? It's going to be a minus. What goes here? 3x. What goes here? A 1. That's factored right there. So the actual factoring part's super easy. Would you agree? It's recognizing what kind of factoring it is. Sometimes they might fool you, and they might say factor something, and you can't factor it. Like, what if they said 9x squared minus 5x plus 1. Could you factor that? Not as a perfect square anyway, okay? Because if I take the square root of that, that's 3, that's 1. If I double that, that's 6. Is this a 6? No, it's not. So you can't factor that. At least right now. Later on, we're going to talk about that, but not right now, okay? What do you think?
It's not that bad.
It's not that bad at all. Let's do one more, and then we'll quit, okay? Let me just do one more. This is example 8. We didn't quite get exactly where I wanted to today. There's one more thing that we have to do, but that's okay. I think we got something accomplished today. So this is 25x squared plus 30x plus 9. Okay, so what if I asked you to factor this? What would you do? Let's take a look. First of all, see if there's any greatest common factor. Does anything divide evenly into 25, 30, and 9?
No.
Well, at first it looks like 5 would go into both of these, but 5 doesn't go into 9 though, does it? Okay? 3 goes into 30 and 9, but it doesn't go into 25. There's no greatest common factor. Always look for that though. Everybody got that? Always look, because eventually you will have some problems where there is going to be a greatest common factor. It's definitely not a difference of 2 squares, all right? So it's possibly a perfect square. Let's see if it is for sure. What's being squared to give you this? 5x. What's being squared to give you this one? 3. So what is that? That's 15x. Then we do what to it? Double it, right? And that's 30x. Is that the middle one? Yes, it is. So is this a perfect square? Absolutely. Now it's super easy to factor, isn't it? Is it minus or plus? Right, because you always look for this sign right here, okay? Now, what goes first? 5x. And what goes next? 3, because 3 is being squared to give you a 9. And that's it. You've just factored it. Okay? There's another one called, let's see what time. Yeah, I only got 2 minutes. There's no way I can get through that one. It's the one that's a little bit trickier. But it's called the sum and difference of 2 cubes. I'll have to talk about that tomorrow. The sum and difference of 2 cubes. Basically, it's this. It's if I ask you to factor this, okay? There's a way to factor that. I don't have enough time. If I had 10 more minutes, I could do this, but I don't. So you may see some stuff with cubes on there. So you're not going to have to do those because we haven't gone over them yet. But here is your homework. And it's, let's see, section R.5. We'll call it A. And then it's page 56. And you're doing 5 to 37 odds. Now, there may be some of these with that cube stuff where you won't be able to do them. I don't know what numbers. I don't have the book in front of me, so I'm not sure what numbers they are. But this is your homework, 5 to 37 odds, and you probably won't, you don't have to do the ones with cubes on them. Everybody hear me on that? Okay. So get that done. We'll take a look at it tomorrow. I'll teach that difference in sum of 2 cubes tomorrow, and then I'll let you get those homework problems done on those problems. Give you a worksheet that's basically the same kind of stuff. And tomorrow's basically question and answer day. All right, so you know how to do this. All right, we'll see you.